Welcome, everybody, to the American Space Museum. I'm Mark Marquette. So glad you're with us to stay curious. Besides a new friend of mine and yours out there, Terry White. Not Josh Dugan there, Marty. Hello, Terry.
I'm doing all right.
And Marty Winkle, my co-producer. And he makes mistakes. I make mistakes. You're going to see one of my big mistakes I'm going to admit to yesterday. I'm so embarrassed I don't know how to spell. But how are you, buddy?
Oh, a little tired.
Tired because of the hurricane. You
Yep.
have a little fruit farm, and you and your wife, Pat, had your hands full last couple
And
of
my
days.
hands picking up all kinds of yard debris and that, and put all kinds of stuff away. So, yes.
Setting up our studio here a little bit. Been one of those days where I've been chasing my tail all day today. And you prefer it be a dog's tail, wouldn't you, instead of a cat's tail? But anyway, we're glad to have Terry on here. Like you said, you have a little fruit operation there with what kind of fruit you have there?
Well, she raises sugar apples and dragon fruit.
Sugar apples.
Yeah, I'll have to bring you one.
Yeah.
I think I brought dragon.
Now,
fruit.
dragon fruit looks like. What's that look like?
Well, it's most of them are red in color and that, but it looks like it's got a bunch of leaves similar to the top of a pineapple.
Yeah.
Yeah.
Right. Yeah.
So,
Right.
and it tastes similar to a kiwi, but I like kiwis and I don't like dragon fruit, but everybody else loves dragon fruit. So.
And you do the star fruit?
Nope, don't raise the star fruits, but and the Japanese persimmons, they're big persimmons. You're probably used to the persimmons, wild persimmons, and that from Ohio and that. And if they're not ripe, they pucker your mouth. These you can eat them green.
All right.
You know, just slice them and eat them. But yeah, so.
Well, we'll be looking forward to those goodies, Terry. Here, it's getting to the holiday season and all, and the season of giving. So great to have Terry here. He's going to do another special show with us today, talking about the thermal protection system of the shuttle, which also applies to all of the current vehicles out there, particularly
they're all using the same thermal protection system the orbiter did, except they're using an ablative material on the underside of the capsules like Apollo, Mercury, and Gemini did, because that area gets too hot.
Mm-hmm.
The orbiter, because of its angle of re-entry, didn't get quite as hot. So,
but all the surfaces around the outside of the
are still
Crew Dragon, and another big one is the Sierra Dream Chaser.
Yes.
Hopefully that'll be flying soon. Well, we've had a lot of activity out there at the Rocket Ranch this last week.
Yep, we're predicting 100 flights this year, and I think we're close to 70 already. So, yeah.
And with a couple lulls in between for some hiccups, but and I know you, like everybody else, Terry, watched the Starship launch and the chopstick catch of the first stage rocket.
Yeah, that impressed me. Yes.
Yeah. What impressed me was our crane operator, facilities manager, Dan McCune, said that when they set that big rocket on the chopsticks, it went into pins in a channel there.
Yeah.
I mean,
it's been a couple years ago. I had a meeting with the manager of the recovery of the segments and that, and he said it was really tough when they were first learning, landing on the barges out in the ocean. He said, but they eventually got their bugs worked out, and they've been doing an excellent job. So.
Well, this catch in that first stage was like the 100th time. It looked so smooth, like a feather on there. And I read that Elon Musk said the next one we're gonna get a tolerance of 1 centimeter accuracy. Yeah. And now this is a game changer. Who needs landing legs anymore? We'll just catch it on Mars and the moon with a set of tongs on a crane there, right? So
different atmosphere there, though, and different landing facility. So.
Well, we hope that you're going to enjoy this conversation. Tell your friends to like us, watch us on the YouTube channel. Also follow us on Facebook. For over 25 years, the American Space Museum has been preserving the birth of the American space age. We are particularly obsessed, if you will, with the shuttle era that here in the 21st century has changed our lives like people really don't understand, do they, Terry?
They do not. No, they don't know of all the benefits they've got from our space program, and especially the Space Shuttle program.
If there was no shuttle, I mean, I don't think the world would be as advanced maybe as we are today.
It would. There's so many things we developed for the vehicle and for the space station, which the shuttle was very instrumental in getting constructed.
We'll talk maybe in November. We'll do have you on in your monthly segment. We'll talk about the Thanksgiving angles of what the spin-offs, as NASA calls them all the time. Well, Terry, we're indebted to GoHistoryTravel.org and the Ramanujan family, who are financial supporters of us, and they're going to help us bring a few astronauts to Shuttle Fest. I got Shuttle Fest way under control. We'll talk about that here in a little bit after our show here, but we'll start promoting the April 11th, 12th, and 13th Shuttle Fest. But GoHistoryTravel.org is a unique little stop as the Ramanujan family, Mal, Ram, and Bharat go traveling around Europe, anywhere, and finding unique ways to present like well-known artifacts or points of interest, like the Roman Colosseum. They found an interesting way to the things that you didn't know, and they're always looking for astronauts.
Okay.
They did a thing on Mike Collins being born in Paris.
Okay.
No, he's born in Rome. Who was born in Paris? Somebody was born in Paris. I know Bill Anders was born in Tokyo, for example. Anyway, check them out. We have a space memorabilia show in a couple weeks at the Beachside Hotel, which when I drove by there Saturday was dark. They had the power knocked out part of the beach over there.
Cocoa Beach sustained some damage from tornadoes.
Yeah, I saw a bank, a Wells Fargo bank, was just like exploded in the middle roof. A tornado touched down there. So we're recovering from that. And it was a mild concussion here for us on the Space Coast compared to what other parts of the country got. But you're looking for a gift for that loved one that loves space, we will have them for you, or buy it yourself there November 2nd at the Beachside Hotel. That's just a block south of Ron John's. And there you are, Terry, giving your free hugs away here to everybody. You've gotten way ahead of Connie now. She's going to be jealous, Connie McDaniel is, because she missed out on her hug today, young lady. And there's your family, Travis, your son that we talk about. Hi, Travis. Peggy, your sister. Peggy's probably watching too. She's got a unique job at the FAA,
Yes,
as we've talked about all these years. Tell us what Travis is up to, our proud, he's in the
well, he just got back
Army.
from Kosovo, and he's in Bulgaria today.
Oh,
Yes.
wow.
Yeah, Bulgaria today. So
Oh,
yeah, he'll be there for a few days.
Uh-huh. He's done 4 tours over there, we recall, right?
Well, he's done 4 tours, 2 in Afghanistan, 2 in Iraq, but then he's been Germany, Sweden, England, and that, and he moves around Europe while he's there, but he's stationed in Poland right now.
Well, that's what one of my joys of doing Stay Curious is getting to know my guests and their families in some regard in there. Terry, speak up there just a little bit more there, my friend. And I've met all your family, and Rebecca's going to be in town. She makes the best gumbo that you've ever tasted. I like her gumbo because you don't need to add anything to it, but I always throw a few shrimp in there or something like that, you know.
Yep.
But anyway, thank you all for your friendship and support of our museum.
Yeah, it's odd. We lost power, and the power crew that showed up to restore power is from Baker, Louisiana, a few miles from Rebecca's house.
Oh my gosh, you
Yeah.
can't make that stuff up, can you? That's what's so fun about, not fun about catastrophes and so forth, but there's always a silver lining. You know, you were involved with the recovery of Columbia, we know that, and still in touch with friends that you made there, aren't you?
Yes.
So we chose as a green screen back here. Marty did. Tell us that day. In fact, you're right over my shoulder. You're right there.
Yeah.
That white shirt, I can tell, with the mustache.
Yeah, that's Atlantis rolling out. I don't know which flight this is for, but it's on its way to the VAB to get mated with the solid rocket boosters and the tank, and then onto the launch pad. So
Now, a lot of people who haven't watched the show before are going to say, what are those yellow things on top of the doors.
Yeah, well, the payload bay doors are designed to operate in zero gravity, so they can't support themselves here on Earth. So those are huge steel strongbacks. We bolt them to the payload bay doors. There's one set that we use in the orbiter processing facilities in the horizontal position. That is the set to be used in the vertical position because we open the payload bay doors again out at the launch pad. Okay, some payloads don't go in till the launch pad. But so those support the doors, and they use a crane system and a weight system so that the doors think they're in zero gravity when they're opening. So, but yeah, that's what those are, and it's on the orbiter is on the orbiter transporter that was originally built for Vandenberg.
Yeah, Slick 6.
Yes, yes, because theirs was a long ride from their processing facility to the pad, so or to where they were going to mate with the boosters in the tank. So they didn't want to roll that far on their flight tires. So that vehicle had 72 tires on it, and it transports the orbiter using the same 3 attach points underneath that we're going to use to attach to the external tank.
Slick
flight.
Slick 6 in Vandenberg, of course, was going to be the military shuttle. Discovery was going to be bought by the Air Force, or sort of, I guess.
Yeah, they put a lot of money into Discovery and Atlantis.
Why Vandenberg? Because that's where, right there at the ocean, they can go south and do polar orbits and be out of.
Yeah, we can't do polar orbits from here.
And that's a military advantage, having the satellites going around the Earth from the poles, because then the Earth turns beneath it and they can move anywhere around the Earth they want to.
In 1970 and 71, I was stationed at Vandenberg.
And really?
Yes.
Okay. 71, huh?
Yes.
Right at the end of Vietnam.
I'd just come back from Vietnam, and they put me in Vandenberg.
Huh. And a lot of the engineers I've talked to, like Clay Walker, who you're going to see some pictures. Hi, Clay, if you're watching. They're glad we didn't launch from Slick 6. It was close to the mountains.
And there was a concern because they had never launched anything more than 3 million pounds thrust, to my knowledge, and they were going to launch this, which is a lot more than 3 million pounds thrust. They were worried about it causing earthquakes. So.
Yeah. I didn't think about earthquakes. It was the tiles coming off from the reverberation off the mountains.
No, the earthquake was the big issue. Yeah, it's right there on the fault.
Right on the Dan Andreas fault there. Yeah.
I think Marty's got a question out there.
Yeah, Marty, go ahead, buddy.
And a question from Dean Babcock. Are tiles removed to allow the rails to be bolted on the orbiter?
Well,
Ooh,
that area of the vehicle does not have tile. It has the Nomex felt, the soft insulation in that. The temperatures up there are relatively low. So this material up there, we would have an access hole to the fastener on the ship to mount it. So we didn't have to remove anything to mount the strongbacks.
Good question there, Dean. We'll look at that some more later.
Yeah, but in response to that, where we do have to remove things to mount things, there are over 600 doors and panels that come on and off of the orbiter as part of its processing. So we don't have to remove the frizzy or the blanket or the tile from that panel. We can unbolt the panel and take it off.
600 tiles. And are these
600 doors? Some of the doors have 30 and 40 tiles on them. Some of them only have one tile on them. Yeah, like to take out a window, there are 4 panels, each of them having 6 tiles that make the perimeter of the window that we have to take off.
We'll see some close-ups of those windows here, as I've chosen some photos in the OPF, Orbital Processing Facility, where Terry was a manager there for a long time.
And just
chose those so because they're unique, and you can
just
really
over your shoulder there is a panel that's off because that's where the forward attach point is for the big fixture that lifts the orbiter. Right down a little bit, right there. Yeah,
right there.
So we fasten a huge.
That's what's attached in the VAB for the lifted up right there.
Yep. And there's another one further back, but So
awesome. Well, we know you're learning a lot. If you got questions like Dean Babcock had, please share them here with Terry. He loves questions. We love answering them here, and I love learning about it there. We got a special wish here today to Mark Usiak, birthday boy. Happy birthday, my friend there. There's your little birthday star floating across the universe there. Of course, Mark Usiak, outstanding photographer with his brother Tom, born in Lancaster, Pennsylvania, and still there. And there he is. He's a Canon man with his equipment there, but one of the real ace photographers out there in the space industry. Happy birthday, Mark Usiak. All right, we'll give you a personal call later. And Amazon lost your gift, so don't even be looking for it. All right. And Marty, you got something to say to Mark on his birthday there? We haven't heard your voice today on that UCAC family microphone.
Well, you have heard my voice because I asked a question from Dean Babcock.
And see, he's always correcting me.
But Mark, young man, have a happy birthday.
All right.
Yeah,
Yeah.
and we told him not to ship your present before the storm, but he did. So.
That's right. We'll have it for you, Shuttle Fest. All right, my friend. Hope you have a great day and keep those f-stops open. You can't print thin negatives, my photo editor used to say. We're going to talk more about it Friday, but this is the Comet that it from my street went outside, and the neighbors wondered what I was doing with the telescope and binoculars. We had a little star party out there. The Comet is right above Terry's head. You can see it streaking up a long tail just to the left of that tree. Yeah, right there it is. And you're probably not going to see it with the naked eye. I couldn't until I took a photo of it and saw where it was, and then I could detect it. It's so for you astronomy types out there, it's only third magnitude. We thought it would get as bright as first magnitude. And Venus to the far left is super bright at -2 magnitude. So, but if you've got a smartphone, one of them fancy iPhones, particularly the newer ones, people were hand holding it, and you could see the comet there. You want to see what professionals see this comet looking like? Go to spaceweather.com, or we'll be showing some on Friday. I'll probably have a comet recap Friday, and going to make a comet out of dry ice for everybody here. Something fun I love to do, and something fun to do on a Friday. So Thursday, we've got Bert Dick of the National Space Society is going to be here. And tomorrow, Wednesday, we have an important board meeting for the American Space Museum that I've been asked to attend. So, and that starts at 4:30. So we're just going to have a short 25-minute show tomorrow. And Marty and I have not pulled that rabbit out of our hat yet, but we'll do something fun and entertaining for y'all. But go out in your driveway, front yard, look to the west where the sun set, and this where you see the bright star Venus. Take 2 hand spans. Take your hands like this and go from Venus over to the right, and it's somewhere in there. But like I said, what I did, Terry, was I put my 35mm camera, or you could do that with any camera, put it on a tripod, and I took I think a 2-second exposure at 1000 ISO, and you'll get something like this. Of course, your street lights are going to be blown out because of the exposure, but that's how you'll see it. And send me some pictures on Facebook if you see it, particularly from those dark sites. Marty's trivia question for yesterday. I really am embarrassed and messed up because I misspelt drag chute. Which shuttle mission and what mission, which shuttle orbiter and what mission was the first to use a drag chute? And that was a complete senior moment. I even asked Marty how to spell it. He spelled it right to me, but I'm so hard of hearing lately. It is CHUTE. And wouldn't you know that YouTube froze the whole show, 40-minute show, to that slide to further insult me. So thank you, Bruce Jacobs, for changing that for me there. But so that comes to bear here's the STS-49. I'm gonna look up what year that was, Terry. Do you remember what year? And you're gonna show.
I don't remember the first one. I know Atlantis was retrofitted here at KSC, had the drag chute installed. Endeavour was the only orbiter that was built with a drag chute.
Okay. This landing was May 16th, 1992. Endeavour's maiden flight, and here we have a shuttle tile. This is the door that we own here at the American Space Museum. All right. And Terry, this feels like it's starched. Okay,
And we
that
do
must
put-
be
we-
the Scotch guard.
No, in this case, on the blankets, the soft goods, we do put a stiffener on the outside. So after it's on and we're satisfied with the installation and that, then the last thing we do is put on, it's called a C9 coating, put a coating on there. So this is one of those 600 doors. You can see around it, it has perimeter panels that go on over that.
Damage from being thrown off.
And
It's hitting the runway, and you
Yeah.
can see that in some shuttle landings. You
yeah,
see
'cause
the door
it's,
come
it's
off.
jettisoned, then the chute starts coming out. Yeah. And it's the chute's actually fired out, I understand, with a 12-inch mortar fires the chute out.
Oh wow.
Yeah.
Well, that the mortar's on the back side then. That's
The
fitted
mortar's
for it.
back here.
Show.
Yeah.
What's that hole for? Show the back side there.
That's not a hole. It's
I mean, not a hole.
Yeah, but
It's an air conditioner.
Yeah.
Air dryer.
and
dryer
I
vent.
don't know exactly what, because I'm not a drag chute guy, but yeah. So
This says door mortar interface plate
so
on that. So let me get that actual artifact here, fans. And thank you, Marty, for your camera work there.
flew into
This is heavy. This weighs about 30 pounds.
flew into space once.
Yeah.
When we ever used a drag chute once, then we put a new drag chute on for the next flight. New drag chute door. So yep.
So that's all the thermal protection system. There's a lot of seamstresses. There's 18
Yeah.
sisters over there. Our friend Jean
And-
Wright, one of them.
And
Those little plugs there.
yeah, they're plugs covering the fasteners. So the mechanical fasteners that hold this door and that on, you still have to protect them. So we
Okay.
make little plugs.
Yeah, zoom in on that, Marty. That one looks like cork right up there.
Well, it's made out of the frizzy.
Oh, it's
so-
made out of the frizzy stuff.
Yeah.
Okay.
So the frizzy you were holding up there a minute ago,
Yeah.
it's made out of that.
All right. Yeah, hold me that frizzy there. Where'd you have that? Yeah. Here we go.
Yeah, we cut plugs out of that, and then we just push them in place.
Gotcha. That's let me show the light
Yeah,
there.
they're made slightly larger than the diameter of the hole, so when you push them in, it just kind of locks them in. But you can see
Everyone would call this felt.
it
All
is.
right,
It's a
pretty much.
Nomex felt.
All right, it's about a quarter of an inch thick.
Yeah. So
All right, and there's the wow. So you got a little plug that
Now-
you carve those out.
yeah.
of.
Now for the ones on the lower surface and that frizzy plug would not hold up to the heat. So we have ceramic plugs that are threaded. That's threaded in glued into the tile, and we screw the insulator in after.
Mhm. And you got the some wording numbers, serial numbers.
That's the
That-
numbers that
all that kind of
tells you
stuff
where it
on
goes,
there.
where it belongs. It traces it all the way back to the original bag of sand that the blanket came from.
And what's that in the inside there? We had some foam pieces
Yeah,
here. It's like cotton.
Yeah, that's aluminum matting, and that's what helps withstand the heat. And then the cloth, I forget the name of the actual cloth, but it resembles fiberglass cloth.
Right.
Yeah, people can't believe that. Yeah.
Space flown, folks. So we have it on display here at the American Space
started
Museum.
out as sand.
Started out as sand there. All right. Well, let's STS-49. There's the logo for it there. We've met quite a few astronauts on this mission, and his famous Bruce Melnick, Kathy Thornton, Thowett. We've met Akers and Hebe. Talked out to Space Center. Not met Chilton or Brandenstein. I haven't. But again, this patch exemplifies what all 5 orbiters were named after. Terry, tell us.
Okay, Endeavour was named after the ship that discovered Australia. That's why it has the British spelling, VOUR.
Yeah.
Yeah.
They were all schooner ships, though, that have discoveries.
Mhm.
Discovery was a Captain Cook
Yes.
English vessel. The 2 flags on top, by the way, they had a contest because Endeavour was the replacement for Challenger.
Correct. It was originally designed and parts of it built before we lost Challenger, but for funding reasons, they had put it on hold. And then when we lost Challenger, they decided to fund completion of Endeavour, and we actually had spare parts for OV-106.
And the flags are a high school and a elementary school that won the contest to name it. Several hundred people chose Endeavour or whatever, so they pulled it out of the hat
Yep.
in there. And if memory serves, I think one of them was in Louisiana and the other one in Arkansas, but don't hold me to that. But Marty, question.
We have two questions. One's from Phil Ramsey, and he's asking why were the tiles counts different on, I assume, identical airframes?
Why were the counts different? Well, the major difference was after Columbia and Challenger were built and were working on Discovery, they had come up with the fibrous insulation blanket. Okay, so it replaced a lot of the white tile. That's why Columbia had almost 32,000 tile on it, and then Discovery, which had a lot of the blankets on it, only had about 26,000 tile on it. So, and eventually we retrofitted Columbia and took off a lot of the tile and put the blankets on, but we never got that opportunity for Challenger. So,
For example, the Ohms pod over Terry's head there that,
Yeah.
that has blankets on it.
yeah, originally it had white tile.
Yeah, and there's blankets along the side.
Yes, on top of the wings, the sides, up on the
Mhm.
payload bay doors, all that on the forward behind you is all pretty much blankets, with the exception of a few,
Good. Who
few
asked
white
that?
tile by Atlantis.
Who asked that question, Marty?
Phil Ramsey.
Phil Ramsey. Hey, Phil. Glad to have you on there. I thought the same thing, Phil, when I saw Atlantis. I'm like, what are these blankets all about? It's like covered in quilts, you
It
know.
is, quilts.
Yeah, come and see us there. Another question, Marty?
From Dean Babcock. Terry, could you describe the procedure of how the tiles are removed in the OPF?
Well, we only remove the ones that are damaged or severely, or the ones that we had to investigate the structure underneath. Like we would take off tiles to go see what was happening with the structure, any hydraulic fluid getting a leak somewhere inside and getting down to the underside of the tiles. So in the earlier days, our criteria was really strict. So there was a lot of tiles that were removed that later on they determined, oh, okay, you can repair those instead. So we did a lot more repairing than we did removing.
Oh, he's asking how are they removed?
Oh, how are they removed? Okay, there's a multitude of ways, but part of my presentation today was to explain the tiles don't get glued directly to the skin of the ship. This is one of the tiles, and this is what we call the inner mold line. This is the part that goes up toward the skin of the ship. But we don't glue the tile directly on there because the ship needs to flex, expand, and contract, and the tile is rigid. No matter how hot or how cold it gets, it doesn't change its shape. So we glue a special pad. Again, it's Nomex felt, just like the Frizzy, but we glue it to the bottom of the tile. Then we
What kind of glue?
room temperature vulcanizing RTV. So it's
Rubberish?
rubberish. Yeah, you use it in form a gasket if you've ever done any work with engines and stuff like that. The closest thing I could say that most people would know is the silicone caulking
Okay.
that you use.
Like
Okay.
aquarium
Yeah,
caulking or
but we don't use it, in a tube like that. We mix it up and put it on. But at any rate, so if I had to remove this tile and I had one of the doors that was off, I could actually come in here with a fillet knife, a very thin knife, and cut through just the felt. I could take the tile off intact, especially if it was a tile I wanted to put back on. Now, we learned sometimes that we were wasting our time because the amount of cracks in there, because every time we bonded a tile, we had to attempt to pull it back off the ship to make sure it was a good bond. Like this tile, we would pull to 250 pounds to attempt to pull it back off. The bond would stay, but we'd literally pull the coating right off of the tile. So we figured we're wasting our time by using one that's probably not going to survive. It's
I'll bet
pull
Dean,
test.
like me, would like to see the tool that you use to do that. I'll have to look those up someday.
Yeah, yep. So, at any rate, so another thing we do if we want to take this off, we want to prevent damage to the tiles around it and that, we would come in here and we would cut into the tile and we would chip the center out, and then the part that didn't have the strain isolator pad, there's a 1/2 inch all the way around it that doesn't have strain isolator pad, then we could take the outer framework right out.
Okay.
That's what we had Jay Honeycutt do one day. So we saved that one for him. Mounted it
I
on
have
our
actually
plaque.
seen that.
Yes,
Yes.
yes, yes.
Yeah,
Yeah, he was a center director.
and
at
I
the
wondered
time.
why it was cut out in the center
So we
there,
could,
and I didn't ask
take
him.
it out and never. Yeah, we chipped the inside out. Now some of them would just chip the entire tile out, in pieces. But
Yeah.
so if we could get access, we could get it off. And if you had to remove several in one area, once you got one off, you could usually cut the others off. And when we first started that process, because they didn't want metal up against the ship and potentially damaging the structure underneath, only a supervisor was allowed to fillet the SIP to get the tile off.
Yeah.
So that was one of the things that I had to do was, as a supervisor, was go cut this off. And then finally I said, look, these guys are competent in that. They can go cut it off. So then they allowed the technicians to do it.
Yeah, that he mentioned Jay Honeycutt, former center director in 95, 96, was your first undercover boss.
Yes.
And he was a good one, I'm sure.
Yeah, it was. We started a program of take the boss to work. So we brought them to work and didn't tell anybody who they were. It didn't take them long to figure out, but
Yeah.
had them go to work, and they got a whole new respect for what the
Jay
technicians
got a lot of
and the
benefit out of
engineers had to
that.
do. Yes.
Well, I've got a couple other things that I lined up before we even talked about tiles, but we've gone out of the chute here really good. One of the important things to remember about STS-49 also, it was the first and only three-person extravehicular activity, as the three astronauts went out there to grab the errant Intel satellite and bring it back in so it could be fixed.
Yeah, never in the history of the program had we done more than 2 astronauts at a time, and neither had the Russians.
And that was Towit, Akers, and Heeb were the three astronauts there. Bruce Melnick took some of the pictures out the window there. He probably took that one. He said that was fascinating to watch. So Marty's got a trivia question today. Marty?
Okay, on STS-41G is known for 2 significant firsts. What are they? And
40?
if you don't know the answer and you look it up, that's fine, but then don't post it. Thank you.
Yeah. Don't post it yet. We'll save it for the end there. 41G. So you got to know your alphabet soup of the 13 missions from 9 to 25 there.
Yeah, that was just a different numbering system for the people tracking all of the costs and all the things associated with that.
Yeah.
And the world decided to go back to STS.
Go back to normal. Yes. We've talked about that. All right. What is STS-41G known for? 2 firsts. All right. Wanted to share a little space history with you today that you are used to the 10-9-8 countdown,
Right.
of course. Did you know that a movie in 1929, Frau im Mond, Woman in the Moon, is where that all came from. These are pictures from this 1929 movie, premiered today. October 15th in Berlin, featured the first rocket countdown. No rocket countdown had been thought about. Now, this is 1929. Of course, the V-2 rockets weren't around, and infant of rocketry with von Goddard is just in its infancy. Well, Fritz Lang provided a realistic portrayal of the rollout and launch of a liquid propellant booster, sending an expedition to the moon. Lang, who is known as the Master of Darkness, created the first countdown. All right. Imagine that. 95 years ago. 10, 9, 8, 3, 2, 1, blast off. Lang has a lot of famous movies, including Metropolis in 1827 and the influential movie M, which is one of the first film noir movies. German rocket scientist Hermann Oberth was hired as a studio tech on this. Unfortunately, they didn't think you needed spacesuits on the moon, and a woman goes to the moon, and she's a photographer. No problem there without a spacesuit. She's got some nice heels on there. It looks
I saw that.
Yeah, it's big clogs. And usually, before we went to the moon in the 60s, the moon was shown as the mountains being very sharp and jagged, which is not the case. They're very fluffy and beat down by micrometeorites over several billion years. So anyway, go check out Woman on the Moon from Iman. That is where we get the countdown on there. And I know you're going to be looking up at the moon tonight, Terry, because it's going to be 13 days old. And I've got Marty talking like an amateur astronomer already. 13, how many days old is the moon? Well, it's 13 days old. 14 is full moon. So one day or zero is actually new moon. So go out and get some moonshine today. So Terry, it's the only kind of moonshine you can't get too much of.
Okay.
And I love the moon, and if some people see the man in the moon or a rabbit in the moon or other things in the moon, and I always see a woman in the moon, outlined by Mare Tranquility and Serenitatis, and her bun on her hair is Mare Chrism, and she's got Tycho, the big crater, raid crater on the bottom, as a pendant. So, hope Marty, I know you don't see that, but maybe other people will see that in there. So, all right, Terry, we there's that picture we got as the screen grab there, and I thought Terry's got a model there. Here are the different areas of the shuttle's thermal protection system.
Yeah, there's the major components that make it up are the black tile.
Here, hold that out in front of
the high temperature tile underneath, okay, and then they see up to 2300 degrees, and then the reinforced carbon is the leading edge of the wing, the nose cap, and then over the forward ET attach point, and they see 3000 degrees on re-entry. Okay,
so that's the hottest, is 3000 at the point.
yeah, at the nose and the leading edge of the wing, and then the on the upper surface, you had originally were what we call low temperature tiles that see less than 1200 degrees, and they'd be along the side walls, on top of the wings, all over the vertical, the orbital maneuvering system, on the top of the crew module and that, and they were replaced, a lot of them were replaced by the blankets later on. And then the Nomex felt is on top of the wings, and it's the only one that is not fragile. So with covers on our shoes or over our feet, we could actually walk out on the wings and not damage the felt. Okay, but and then on top of the payload bay doors, down the side walls of the vehicle, and on the very top of the crew module, up by the upper windows of that, is the Nomex felt.
And we're going to feature the cabin area here in just a minute. And this was probably a very much desired photograph here. This is STS-3, Jack Lausma and Gordon Fullerton coming in to White Sands. This is the photograph of the underbelly and the heat structure there. So I assume that the red is the hottest, Terry, and the yellow,
yeah, and
and
I don't
the
know
blue's
what
the coolest.
I don't know what point in reentry they
Right,
showed
correct.
that, but up by the nose and just next to the reinforced carbon along the leading edge of the wing and back on the body flap is the hottest
Yeah,
parts.
so purple would be the hottest,
yeah,
there, no matter
so,
what.
Yeah, so
So the yellow and red would actually be the least, probably, huh?
probably the least, yes.
All right.
Yeah.
Such data like this helped you guys make
Yeah.
better tile and
Because
so forth.
up at the nose and out along the leading edge of the wing and back on the body flap, the tiles were 4 inches thick. And as you went into the middle, and you could look on that to the left that you're seeing the orbiter there, you can see the main landing gear door, and right by there, the tiles are only 1 inch thick.
We're going to show 2 pictures of tiles on the vehicle and then show you how tiles are made in a furnace here. But there you're looking at a couple.
Yeah, you're looking at the elevons and the body flap up the top, and then over to the side, you're looking at the other way.
Let's see. Yeah, Marty.
Right over in front of you. They're looking at the external tank door, and then
See the square there, Marty? Right near the edge there. Point out the external
over to
tank
the left
door.
of the photo.
And then the other's the landing gear.
Yeah, and then down right above my name is the landing gear.
That's your landing
That's the landing gear door. Yeah, and then go up higher, Marty, and go. Yep, and that door right there is the external tank door.
Now I see different colored tiles there. Of course, the black ones stick out, and
Okay.
then you see the patina of
Yeah.
of a
Yeah.
previous re-entry on there. So
Yep. They all look nice and pristine black when they were brand new. Okay. And then the heat of reentry turns them grayer and then grayer. So all those gray tile you see out there, light gray, have been on for all the flights of that orbiter.
huh.
Yeah. So the black ones are ones we replaced. The shiny black ones only had 1 or 2 flights on them, and the others that are not really dull gray but have different shades of gray may have been replaced 5 flights ago, 10 flights ago.
Was that a surprise to see the color change when Columbia came back after?
Well, after the first flight, you didn't see a lot of color change. You saw a lot of streaking, which really defined where the heat was and what the flow of air was, and it surprised some of the original engineers as to, they were off on their calculations of what the airflow would be.
Right.
So, yeah.
Yeah, that's one thing when you see Atlantis, you see the flow across there, and like you've said many times, that was like an ink blot print of what was going on.
Yeah.
This is almost 8-inch square, I suppose, something like
6
that.
inch.
I mean, it feels like I'm holding like 3 marshmallows.
Yeah.
I mean, I'm serious. It is that light. It's
Yeah.
really light.
Well, and then this is the thinnest one off the ship, and it feels super
that's-
light.
Yeah, yeah. And look at the thin one there. Where would that be?
That was on the forward row of the aft row of the forward reactionary control system. You can't see it, but that goes up just forward of the windows up
Oh, we'll
there.
see
If
that
you
here in a
flip
few
back to
minutes.
one of the other photos, yeah, you can see. But that is the thinnest tile from the ship, and the one you're holding actually flew in space.
about a half an inch.
Yeah, I
looks
think
like
that
there.
one flew on Endeavour.
All right. And there's a cool picture that I asked Terry where he thinks that was taken. Probably from the ISS. There's the hatch. I can see the yellow arrow pointing to the hatch there. You got the Earth in the background. I've never seen that photo. That's why I threw it in there.
Yeah, you see the dark cluster of tiles right above my head? That is where one of the antennas is. So we periodically remove the antennas.
Oh, okay.
And so that would
right
get
there.
that would get new tile, that there was no problem with the tile, but in the early days we had a lot of problems with the antennas.
A lot of hidden hardware underneath the tiles, like antennas.
Yes. Yeah.
What
so-
other things would be under the tiles that we wouldn't think
Well,
about?
a lot of the instrumentation. Now, Columbia had the instrumentation on it, but there was a lot of different temperature sensors and acoustical sensors and all that were in the tile.
Uh-huh.
But yeah, so
Marty's got a question.
Got a comment from Bill Whiting. Jack Glassman once told me that that tiles were bouncing off of the windshield during the launch of SCS-3. Any comment on that, Terry?
well, I don't recall them coming off on STS-3. They did on STS-1, but we had tiles that were called dice tiles because of the flexibility in that. We would fabricate an 8-inch tile, and then we would cut it into 16 small pieces, but the strain isolator pads still kept them together. So if you've ever done the multi-tile for a bathroom floor, that's
Right,
you
yeah.
flex on it. So that's to allow them to flex in flight, but we had to cut them before we put them on the ship because we couldn't go cutting the tiles once we were on the ship. But yeah, so they would go. Now, if we lost some segments off of there, but I thought by STS-3 we had replaced all the ones. On STS-1 we lost a lot of segments, and we lost some whole tiles on that. Again, but because of the densification process where we were originally installing the tile like this, and watch when I rub the bottom of the tile, this is the pure silica, and it comes off on my thumb. I don't know if you can see that very well,
Like
but
a chalk.
yeah, it is. So when we glued the strain isolator pad to the chalk, it would peel right off. So before we ever flew STS-1, we knew we had to do something different, so we went out and hardened the bottom of the tile, and instead of being that white, you could see after we hardened it, it turned it gray.
Oh, yeah.
And then when we glued the pad on the gray tile, because one used to be glued to the gray surface, one used to be glued on here, you could not peel it off. This one had to be shaved off with a razor knife after we took it off the ship. And you could see the red adhesive right there that held it on. So that's sand.
Yeah.
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 So
We got space flown stuff all
yeah.
over us.
So
here.
before STS-1, NASA decided to go fly before we had hardened all of the tile on the ship. So
Wow.
to harden them, we had to take them off of the ship, send them to the back shop. They hardened them, rebaked them in the oven, waterproofed them again, and sent them back to us. And then we could put the strain isolator pad on after we had fit them again and put them back on the ship. But they opted, since we had the lower surface all done, to go fly, and we lost a lot of tile off of the upper surface or pieces of tile.
Not heard Jack Lousmith say that, Dave Stange, but I'll ask him.
That's Bill Whiting.
Oh, Bill Whiting, but hopefully get to see him at the Space Center again. We'll ask him that. But
Yeah, somewhere in my records, I have the number of tiles that we replaced each flow.
uh-huh.
And I don't recall what the number was from STS3. So.
Well, good segue about baking the tiles, because Terry's going to explain this young lady probably 15 years ago. She's not baking cookies.
Nope.
Thank you, Clay Walker. Again, these are Clay Walker's photos he shared with us.
So a tile goes through multiple times in the oven to be baked. It starts out and they make it into a slurry, fabricate it into the tile shape, press the water out, and it's a billet that they do. And then a machinist machines it to the exact shape that you need it for that particular cavity on the ship. Okay. Then once that's done, then it goes and it gets coated. So this is a high temperature tile, but it's been coated now on 5 sides. It's not coated on the bottom. That's the side that eventually we're going to densify, but we leave about an inch thickness of the white silica there, and it gets baked in the oven, and that's what finally sets it in that and makes it the tile. Then it comes out and they machine that bottom based on what the exact contour underneath the tile is. And for stress reasons, it's really important that the bottom of the tile exactly match the skin of the ship where it's going, even though you're going to put a strain isolator pad on there, but that has to match. The one I'm holding in my hand, there could be no deviations between this and the skin of the outer skin of the ship of greater than 5/1000ths of an inch. The
wow.
majority of them, it could be no deviation greater than 19/1000ths of an inch. So we had to do a lot of what we call filling and fairing. So we had to go in there. If there was a slightest little dimple in the skin of the ship or what, we had to fill that in with the adhesive and that, and sand it all down and get it smooth so that we knew that the bottom of the tile and the outside skin of the ship were exactly the same.
How hot is the oven?
It's 2200 degrees, I think. Yeah.
Look at the heat radiating off the bottom of that tile.
Yeah. Yeah. It's glowing.
Now, what
When you
surprises me is you're not mass producing like 100 at a time.
Not
You
a
got
Kennedy Space Center,
you got 6 tiles there.
Yeah.
And you only need
well, then you don't have
19,000.
six those 4 white blocks up there.
Yeah.
That's just to support the tile.
Oh, okay.
You
Those
may
are-
have had 2 tiles in that bake in the oven.
I got you. So
Yeah.
the blocks are not tiled.
And now where they build them at Sunnyvale, I don't know how many Lockheed was baking at one time in the oven, but Palmdale had basically the same kind of thing. For a long time, KSC was not able to fabricate tile. We would have to get them from California.
And T-38 with an astronaut might bring
For
it to you
a
at the
real
last
critical
minute.
one, yes.
That's amazing. Marty, you got a question from one of our Stay Curious watchers?
That's me.
Okay, you. All right.
How long does the process take to create a tile?
That's a very good question.
Of course.
Okay, so when we determine a tile has to come off of the ship, then if we are satisfied with the one that was on there that it fit good, then we can order a replacement tile, which they can start fabricating if it's a computer program tile. Okay, the machinist can build it according to the thing. If they don't have the program for it, we have to go get the tile off the ship, and then we actually have a pattern maker who comes out and builds a pattern out of foam to exactly match that cavity on the ship and to what the engineer is looking for in the way of our flushness, which we call step, and our gaps in between the tiles, because there has to be gaps between the tiles again, because the ship flexes and we don't want the tile, they have to be able to move. So at any rate, so we do that. If they're fabricating the tile, it takes them several days to fabricate the tile. Once we get the residual glue out of the cavity on the ship. Then we get the new tile, we fit it. We're checking its gaps to make sure it fits properly in there according to what the drawing is. And the drawing can call out that the gap has to be at least 19 thousandths of an inch and can't exceed 30 thousandths of an inch. So you have a very tight gap. Where you go back to areas in the back of the ship where there's a little more flexing in that, you may have 100 thousandths gap in between there, but we put a gap filler on the upper surface. You may have a 75 thousandths gap that we don't put anything in. So it depends where it's at on the ship. But so we do its first initial fit. If we're satisfied with the fit, then we send the tile back to the fabrication at the back shop where the oven was, and then they will harden the bottom of the tile. Like I said, they will densify it, so now it's hard. You can't wipe anything away on it. So once it's hardened, then they bake it in the oven again, and then they put it through a waterproofing process, and then they send it back over to us, and now we have to go fit it again just to make sure that they didn't wash anything out, because it's done by a technician by hand, uses special pads and pushes that slurry into the back of the tile to harden it.
Labor intensive, isn't it?
It is.
Viewers out there, wow.
And then it comes back to us again after a couple of days, and we fit it again on the ship. We're satisfied that the way it fits. Then we send it back to the back shop again, the thermal protection facility. And now is when they cut and glue the strain isolator pad to the back of the tile. Then they send it back over, and now we do its final fit. It has a strain isolator pad on. We fit it to the cavity again. We're still on a go with everything that's going on. And now then the technician will start the process of cleaning the skin of the ship. And there's a bunch of different types of skin on the outside of that vehicle. The majority of it is aluminum, but the antennas are not aluminum. So that you have composites. You also have epoxy graphite structure. You have titanium structure. You have beryllium structure. You have Inconel structure. So you have all kinds of, and each one of them has a different process to get them perfectly clean. And then we prime them so that the adhesive sticks.
Well,
And that's just getting the tile glued. Now, once we glue it on, it stays under pressure until we're sure the glue has dried. So we make a sample of the glue and we keep track of it. Well, once it is dried, then we go and we attempt to pull the tile back off. I was telling Mark earlier, this tile here, we would pull, because it has a 25 square inch strain isolator pad, we would pull it to 250 pounds to attempt to pull it back off the ship. If it passed its pull test and we're satisfied, then we do the final measurements of its gaps and its flushness to the other tiles around it. And then we do any subsequent rework that has to be done with that, any design gap fillers that have to go in. So you're talking about 2 weeks if you were replacing a single tile.
2 weeks is Marty's answer there. And how many feet of paperwork is involved there? I mean, it sounds like a lot of paperwork.
It is. A
Clipboards, you're checking this off.
Oh,
you're
and
going
you got
over it.
people looking over your shoulder. You got quality, you got NASA quality and all that. But yeah, volumes of
I don't
paperwork.
think our viewers that are so intelligent realize
Well,
the complexity of all
They
this.
used to tell me if you stack the paper sheet on top of sheet, what it took to get an orbiter ready for one flight, it would exceed orbit.
Really?
Yeah, so you're talking almost 150 miles of paper.
Stacked as a single sheet. Wow, that's 20-pound paper, 150 miles. I believe it. That's like Marty's Grumman lunar module and the whole Apollo program. They could have just stacked the paperwork and walked to the moon.
Yeah.
You know.
But it is manned flight, so you have to track everything back.
Now I got a question.
Yeah, by this part number on the tile, they could track it all the way back to the original bag of sand that it came from.
Is that right? There's your VT is the key number for.
Yeah, now that one tells me VT means it's a test tile. That's one we built after the Columbia incident to do a bunch of extra testing on, where the one like this one is a VO70. So that means it's for a space shuttle orbiter.
Now, what's that hole in there for?
That one goes on one of those 600 doors, so that's where you access.
Let me get my eyeball in
Yeah,
there.
so you access the fastener that's there. Now that one's on the upper surface, so you don't need to put the plug in there, but on the side walls of that, it would, or on the lower surface, it would have ceramic plugs in it.
Looks like somebody started drilling in the wrong place.
Yeah.
Right there. Is that
Well,
what
no, the other one,
Yeah.
that's the waterproofing. That other.
Oh, that's
yeah.
the waterproof. All right.
That's where we would inject the waterproofing solution, the dimethyl silicate, into the tile. If you look real
My
close, there's a
fingers.
little tiny needle hole right in the
There
middle of that.
certainly is.
Yeah, and so we use a needleless injection gun and inject the DMES into that tile, and then it's waterproofed again.
Yeah, Terry talked about that last month, about they used Scotch Guard off the shelf.
As when we first
and,
discovered the problem, but yeah, so.
How much attention to this detail you just explained do you think the new Renaissance companies are doing?
They pretty much have to do the same thing. You have to go do an inspection of all of your hardware before you're going to fly that capsule again.
Mhm.
So, you have to go out there and look at it real close and see. I haven't worked on any of them, but I understand some of them, they have panels that if you have several of them, they just take that panel off and rework it on the bench and put another panel back on the ship.
Well, I'm sure there's some former people that work for you in some of these companies.
They are.
Leading.
But they're reaching retirement now. More and more of them are retiring from
Yeah, that is
from Lockheed and
that
Blue
is a
Origin and
consideration.
SpaceX. So
Passing on the legacy of the thermal protection system. Glad you're with us today with Terry White. We got a few more slides to show you. You mentioned the computer generated tile.
yeah,
What are we looking at here?
that's
Or
a
is
little hard to tell
I
exactly
mean,
what
but that's what we're looking at. Something.
but the machinist, if he's got it, he puts the billet in there and then machines it according to what the
This is 1990s technology, maybe. Okay.
yeah.
And that's what my point also about all of the paperwork involved is today people would just have a smart tablet or stuff like that
And
and
it's
go
still a lot of it's still backed up by paper,
all right.
or it was when I was still working, even though they were coming out with the computer.
So there we're looking at one tile.
Yeah, and I don't know exactly what that is being baked without,
Right.
yeah. So,
But
and I don't know the shapes of some of. I've only been around some of the new capsules.
well, we got
Short visits.
and there's there's a technician working with a tile.
He used to be a tech, then he went to quality, and he's inspecting the strain isolator pad on the back of the tile. You can see this pad. That's what's right there underneath his thumbs.
Uh-huh.
Yeah.
So
So he's looking at the white side of it. So
And like when Terry and I were talking before the show, I go, how is that the tote box that you
That's
put
what-
them in to
that's
take
what
them
we'll
over
put
the
'em in, take
OPM?
'em across the street, so it gets transported back and forth right across the
You had to
street.
take care of them in
Yeah.
transit and everything
Yeah.
like that. So that was your little system. What's
And-
in the
and-
background
and you,
there?
And you
on
had
the,
to
the
be
workbench?
certified to even handle the tile. So for a long time, logistics could not move the tile because they weren't certified to handle the tile.
So if the box was on top of your lunch box, you couldn't move it out of the way. Huh?
No, but the technicians actually moved the tile from across the street instead of logistics. So, at any rate, that is a vacuum bag setup back there. They're
Oh.
probably got tiles that they're gluing more SIP on, and they to apply pressure to it, they put it in a bag that they vacuum it down and sandwich it in, and that holds it for its cure, which is in Florida, temperature and humidity, it's usually 6 to 8 hours.
One thing that always, Marty, you can address this too. Workers came and just wore what they wanted to at work. Was there? I mean, he's got a nice T-shirt on there. Was there memos going around? No rock and roll T-shirts or?
Well, if you go way back into the early days of the shuttle and that, we didn't have uniforms. People
Right.
wore clothes like that. The people that came here, TDY from California, they,
You could take care of that there. Another one of his fans after him.
but they,
The uniform. You never adopted a uniform.
yeah, but
Everybody
some of the
just
ones
wore
that
what they
came from
wanted.
California did not have the proper clothing. They were exposing too much skin.
Uh-huh.
So, and they were union. So our management here didn't like it, but the California management said no, but they did correct a lot of those. But we did have one of the higher ups from the company came in one night, was wandering around and saw a bunch of technicians sitting around a table and got really pissed and went to chew out the management, and come to find out they were not our company employees. They were someone else's employees. So
Yeah.
the next week we had uniforms.
Right. That section of the work there, or everybody. Yeah.
Every technician for the company was issued
Okay.
Rockwell Blues.
Rockwell Blues. Oh yeah, that was Rockwell. They wanted to know their employees separate from KSC
Yeah, he
employees
didn't
of yours.
want to waste
or
his
whatever
time
like that.
chewing somebody.
Yeah. I've heard that story a couple times in other vernaculars. Yes, Marty.
Yeah, that goes back to the Apollo days with Grumman, and it was DJ O'Malley who had all his technicians wear blue uniforms,
Yeah.
coveralls.
Yep. Yeah, that's what he was the one who implemented it for Shuttle too.
Yeah,
Well, it just carried over. I think it just carried over from Apollo into Shuttle.
Well, there was a gap, but yeah, when he got pissed,
yeah, it took it over. Well, I mean, also Florida weather. You're inside, outside. People want to be comfortable. I mean, it's a lifestyle here that I've acquired over the years. It's sort of like in February, I'm going, is this all I need? It's like, underwear, pants, a shirt. Not only need socks for my shoes,
the females wore jackets in the OPF because for the orbiter we kept the temperature at 68 degrees all the time.
Why? Electronics?
Yes, because of all the hardware and everything. Yeah, we had parameters that we had to maintain. That's why we could only keep it outside for a shortened period of time going to the VAB and the pad.
Hope you're enjoying this show. We've got a question out there. What were the two significant events of STS 41G? Right, Marty? We're going to answer that question here in a minute. And got a couple other pictures to show. We've had a nice, just some more of that beautiful tile footage there. Yeah, that looks nice, doesn't it?
You need the photo of them holding a piece of the tile before it's coated when it comes right out of the oven and picking it up with their bare hands and it's not burning you.
Yeah, that's amazing. You could have a blowtorch on one side of it or a welder's torch and not feel the heat on the other side of it. We're going to quickly go in the OPF, look at the front end of this beautiful orbiter. I errantly thought there was 4 windows on the front. Now I know there's 6.
Correct.
Because Marty's question a couple days ago was how many windows are on the orbiter, and you
11.
know that
11.
11. There
Yep.
you go, just like on a football team. Marty, question.
Yeah, Cliff Watson's asking, so how do you attach something to the tile to make a pull test?
Okay. Well, it was in one of the pictures earlier, but we have a special vacuum chuck that we mold to each particular tile, and then we hold it onto the tile by vacuum. So it has another piece of the strain isolator pad, and it allows it to draw the vacuum down, and it has a gasket around the outside, and it actually is cast exactly to the shape of the tile and is held down by vacuum. And then the fixture has a threaded thing, and we install a threaded instrument in there, and then we have load cells, and then we set back and pull it to the desired thing. So that is a science in itself, and pull testing all of them, because you also have to make sure about how much it wiggles, and you have to pull directly in line, or you can actually break the tile because you're not pulling through the center.
A lot of suction on that, which to
It
me,
is. It
to me
is.
means a lot of noise from
Yeah.
a machine.
Well,
This
yeah.
is a noisy process.
Yeah. Well, the vacuum is not too noisy, but still, you're going to pull that to 250 pounds, so you're going to pull really hard against it. So.
Great to hear from you, Cliff Watson. He's in Pomona, Australia. Good Wednesday morning to him there. We're still getting through our Tuesday here on Stay Curious. Enjoying Terry White. Once a month he joins us, talks just like this to you Stay Curious watchers out there about the wonderful shuttle era that he spent over 30 years of his life involved with. Go ahead, Marty, with another question.
Yeah, Mitch from Man Space is asking, why the black tiles around the windshield?
Okay.
Let's get that a little closer
Yeah,
up there.
Again, we wanted the high strength. The window area is one of the most fragile areas on the vehicle. So we wanted the stronger tile there, and we used where the tile Mark was holding weighs 9 pounds per cubic foot. The tiles around the windows weigh 22 pounds per cubic foot. They're a lot denser material, a lot stronger, but on re-entry, that area around the windows gets hotter, and they want to give it the most protection. You see, even between the windows 3 and 4, it's all black tile there because of the heat coming up over the nose. So even though, 3 inches away from it, you have the 1,200 or less tiles. But that's a good show where you can, a view where you can see above my head, you can see the white tiles right there, and then back of them you can see the felt, including where the
All right, so this is tile, that's felt.
yeah, and up top is windows 7 and 8. Those are the observation windows. Again, they have the high temperature tile around them. And the red triangle right there, you know what that is?
Rescue.
Correct. Yep. So yeah.
And there's actually in that tile frame, that window frame, are rope, right?
there's
that-
gap. Well,
The rope that they would throw out to climb out.
oh, I don't know. I never looked at the rope on the inside. So
Yeah, well, I was told that by
Yeah,
an
it
astronaut that
should
there was
be.
rope there that
Yeah.
they were. I think that was Charlie Walker telling us that, Marty, that he trained and that to get out you had to
you had to
bust
be able
those
to get
windows
down.
out.
Yeah.
And I go, how'd you get out? He said they had rope there that you pull out just a
Yeah.
thing of rope and have
You
to
didn't have to
shimmy
bust
down.
the windows. Those were pyro windows. You
Oh,
pull
okay.
this control and it blows the window out.
Well.
Just like a hatch on an aircraft. So.
All right, don't touch that button,
Yeah.
Mark. On there. Well, that's interesting. That's felt, that's tile, and this is heavy duty tile there on our windows there. Again, a couple unique perspectives there.
Yeah,
So
that shows you, and that thinnest tile is on the black row just forward of the white area right there. It's the forward reactionary control system. Yeah.
mhm.
Okay. We can take that off of the ship to do maintenance down at the Hypergol facility because that has the monomethyl hydrazine and the nitrogen tetroxide.
That whole section is lifted
You
out.
Can
and-
lift
and-
out,
and
yeah.
it's
So you have to take off all the panels around it. You have to take off the servicing panels to service that at the pad or on the sides. And you can see 3 of the big thrusters there. Behind there's 3 smaller thrusters. Then over my shoulder is 5 thrusters on either side, giving you 16 thrusters on the forward. Also in that picture, you get a good view of the heat marks, and that's outgassing. Just forward of the thrusters, you see the white on the tiles.
Mhm.
Yeah, that shows you the actual flow of heat on reentry. And on over my shoulder, you
Point
can
that
see-
out,
you
Marty.
can
The
s-
white
yeah, you can see-
areas off the.
yeah, over my
Point,
shoulder,
thank
right
you.
here underneath my hand now, you can see the streaks going up. So because of the angle that the orbiter comes in,
Yeah.
you're getting heat coming
Oh,
up this
yeah,
way, but
so
on the
it's-
side, it's coming right up this at about a 45-degree angle coming up the sides of the
I'm
ship.
going to look for that on Atlantis when I look at
Oh,
it.
you
And
can
then the
s-
ones
you-
on the
you-
nose
yep,
there.
that's what I point out when I was
In there.
giving information there.
Once again, this is an orbiter in the orbital processing facility, the 3 buildings around the VAB, and look at the tight fit of everything in there.
Oh yeah, we close up all the gaps around the orbiter so that we can work on it to less than 12 inches so we don't have to wear fall protection. Our fall protection tended to damage the orbiter, so we close everything up. And you can see underneath one of the platforms right above my head, you see a yellow
Sure do. Yellow tag thing there.
and then right above the yellow thing is the Star Tracker door. Right where your
Okay.
hand is now,
Yeah.
there's 2 Star Tracker doors, and that's what they use to navigate when they're in space. So once they get up there, that door cycles, and 2 instruments look out at the orbiter knows the location of
It's closed right now.
50 common stars, and they can tell exactly where they are.
Is that a slide back type of thing?
It
or
rotates around, but
rotates-
it's in a recessed area, so it's down several inches
Yeah, I
below
noticed
the
the
out.
recess, yeah.
And then that door cycles out of the way.
Well, I know Doug Forrest in Los Angeles is enjoying this. Hello, my daughter Jessie Q and McKinley. Hi, McKinley. She's gonna be 3 in about a week here. So, and Macy, my 1-year-old granddaughter there. So, Mitch at Man Space is watching. Tom UCX watching. Steve Jokums, do he'd be watching, and his Lake County Spaceport up there at the Lake Michigan area. And Lake County Spaceport's where you get your shuttle decals to make your shuttle look authentic from Mr. Steve J. Dean Babcock, thank you for watching. Carlton Bailey, always watching us there. CB put his excellent shots of the Falcon Heavy on Facebook yesterday. Tom Celentano's watching. Your sister Peggy Holbert. Hello, Peggy. Bill Whiting's watching up in Michigan. Phil Ramsey. Lynn Feather. Is that one of your kin?
She was my admin.
Oh, okay. Admin Lynn. Good to see you, Lynn. Lee
She's
Wilson.
in West Virginia.
Lee Wilson, top communicator out there. Lee, put a show together for us again. We'll have you on in November. Pick what you want to talk about.
And my wife.
And your wife, Patty, there. Hey, Pat. He's sitting here, Ratchet John, and you're doing the hard work there on the farm. So,
Well, she used to do the work on that. She started out as a technician on the thermal protection.
is that how y'all
system,
met?
And then
The romance started there?
no,
Huh?
but
Oh.
and then she became a supervisor for a while, and then when Rebecca was born, we decided she could stay home. So
Well, I always enjoy seeing Pat and your sister Peggy and your whole family, like we said. Part of what our family is all about here at the American Space Museum, we consider all of you family members. The Usiak brothers and Bill Whiting and Doug Forrest, just been with us such a long time. Carlton Bailey, Tom Celentano, you all just like family to us, right, Marty? You got a question there?
I got a question from Michael Bruno. Do you think repair of the Columbia RCC was possible in orbit?
no,
All right.
it was.
That's
We-
what
we-
we're talking about. We know
yeah.
something
We
hit.
only did
right there.
minor repairs of the reinforced carbon, but no, there was no way. It was way too big a hole, and they even calculated, well, what if we had, offloaded as much as we could, made the orbiter lighter, which means it shouldn't get as hot, and we came in and overtemp the right wing to try
Right.
and lower temperature on the left wing, and they said no way because of the extent of the damage. There's no way the orbiter would survive. So
All right. But there was a rescue plan that was never implemented with another orbiter. We'll maybe talk about that one day. Mike Leinbach's alluded to it a little bit. But what a drama that would have been to live out. So good question there. Thank you very much. Let's answer Marty's question here. Space trivia question. STS-41G is known for two firsts. What are they? And who's got the correct answer, Marty?
Steve Holcomb's the only one who got the right answer.
Steve Jocum's the only one?
Yep.
That doesn't surprise me that Steve got it, but I can't believe. But go ahead. What are the two significant firsts, Marty?
Well, two American women in space, and the first spacewalk by a woman, which was Kathy Sullivan.
Yep, we have Kathy's handprints here. She just had a birthday recently. Her prints are in our women's gallery. She was also a big oceanographer. She was over the that division under the Obama administration. So, good question, Marty. Thank you, Steve Jocums.
I haven't got to that chapter in the book. I'm listening to the book of the first 6 female astronauts.
Oh, are you?
Yeah, and that will come up. So
All right, good. Yeah. What's the name of that book? I haven't
I'll give it to you.
put
after
that
us.
on my
It's all-
radar.
Yeah. So
You have books on tape or
Yeah.
books on the?
yeah, I get them from the library. So yeah.
I'll check that out then, my friend. And let's go out with John Tribe, a legend of NASA, just like you are, Terry. What a great guy, huh?
Isn't he?
John there, just I enjoy having lunch with him once a month. Great. He's one of the first British engineers to come over here. He talks about his uncle being killed by a V2 bomb as he was an 8-year-old boy in a bomb shelter. And then 20 years later, he's sitting beside Wernher von Braun at a launch of a rocket, and it got scrubbed. And Werner just said, well, sometimes we don't go.
Yeah.
That's what John said was his big interaction with Wernher von Braun. Held no grudges against the man, though the V2 rockets killed a family member. So what a great guy. And we'll be seeing him out at the Rocket Ranch reunion in November.
Yeah, he worked at Apollo and shuttle.
Yeah,
so.
he's a hypergolics expert there.
Yep.
Mr. John Tribe talking to Terry White there about a year ago. And Go History Travel, thank you for your support of our museum. You too can support us, and we'll be talking about you on our show here. Let's get off of there. And thank you all for watching today. We've had a great show, learned a lot, what in-depth details these tiles were. And the I know one of the things that Mr. Honeycutt's proud of was cutting the turnaround time from an orbiter from 1,500,000 hours to just around 1,000,000 hours. My figures are correct, right?
Mhm.
And that was a big plus in 1995 and 6 during the Honeycutt era there at Space Center. So it takes a lot of time and a lot of people involved to just put our precious cargo humans in space. So Terry, thank you. Anything else you wanted to add?
No, that was it. Just say hi to the family, all of them that are listening today. So
All right, good. Marty, thank you for a great Streamlabs job today. Thank you all for watching. Tomorrow we'll have I'll guarantee you we'll have a 25 minute program that you'll not want to miss. Thursday I have Bert Dick on the program. He is the managing director for the National Space Society, a great guy. He's been well connected in the space community for probably 30 years, and he just came from some conference that's talking about habitats on asteroids, planets, wherever. So Bert will be on Friday or Thursday, and Friday I am going to astound you all with a little science. I'm going to make a comet out of dry ice, and we'll go over all the beautiful comet pictures of this comet Tashenshin that is in your sky tonight. Go out and check it out. It's hard to see, but you'll probably have a good photo of it and then see it after the photo. So until tomorrow, I'm Mark Marquette saying I can't wait to see you in our museum to bridge the space between us.